Hello everyone, my name is Anton. After my articles and videos about 3D cameras, one of the most popular questions was which 2D camera should I choose for my project? This question, it seemed like easier than the question about 3D cameras, but it's in orders of magnitude more complicated than it seemed. And even in this video and in the supplementary articles, link of which you can find in the description, there will be no answer for this question, like an internal answer. But you can find a lot of ideas, a lot of techniques how you can choose 2D camera specifically for your project. Also, I need to mention that this question, there are a lot of people who can have completely different view on the solution of this question. And for example, if the person is more oriented on some camera prototyping, it's one approach. If person is like in video analytics, it's maybe a completely different approach. So for this video and this article, I asked 3 experts, Pavel, Yuri, and Andrei, to criticize these articles and to send me a few ideas. So I put link on their LinkedIn also in the description. So thank them for the help. It was definitely super helpful. But also I need to mention that a lot of these recommendations, they were contradicting each other, because different people has different experience and different view on this problem. And it's super hard and the complex question where you can find a lot of viable solution, but they may contradict each other. So, general logic. When choosing a camera, you need to evaluate several general characteristics on the high level. For example, how many frames per second do you need to process? 1 frame per second is sufficient actually for a lot of questions. For example, if you need to create parking ticket, or for example, if you need to monitor amount of people in the room, or if you need to monitor some animals near near your camera, sometimes it's even enough to have 1 recognition per 10 seconds. And of course, in this case, you don't need super accurate latency and super big speed. But of course, if you need to track eye movement for top solution, it's required to have 500 FPS, maybe even 1000 frames per second. Second general question. Which volume do you need to analyze? Which angle, which resolution you need for this volume, which depth field. And for determining this, you need to choose metrics and optics. And we will speak a little bit about them a little bit later. The third general question is stability of lighting. Because if light, it's determine 90% of quality. And when you're speaking about having a good 2D camera, you also need to understand can you use additional lighting, which spectrum this lighting can be. If you can't use how much money you can spend on your lenses, because of course if you take big lens with good light sensitivity, you may not use additional lighting, but the price of this optical system will be much higher than the price of your light system. The fourth general question: where do you need to process your images? It may be like the same chip as the camera, it may be like in your server room, or maybe it will be like the server room on another part of the world, or maybe it like will be PC in your car, while the cameras, there will be a lot of cameras around. And in all of these cases, connectivity and cameras, they may be completely different. So, to estimate all these four general questions, I created small table. It's really small because a lot of these branches, they can be like increased, like and you can create a lot of additional leaves on each one of them. But in my opinion, maybe it's like the critical minimum that you need to determine when you need to choose your camera. At least you need like to think a bit about them. So let's start with camera connectivity type, like interfaces. And for them, like let's discuss the first. It's like the protocol of your camera connectivity. It will affect like speed, it will affect like bandwidth, and of course it can affect like your resolution and so on. And we will speak about USB, CSI, and LAN protocols like a little bit later. We will like spend a lot of time for each time of these connectors, because it's like 90% of available technologies, maybe like even more, 95 or maybe more. But here I will speak a little bit about other variants and other technologies. Just a few brief words. First of all, of course, it's like PCI-Express. PCI-Express, it's today's like general communication way between like processor of your board and any other peripherals. Of course, like if you're working with some ESP32, it's not like this, but in all other cases, usually like even like USB protocol, LAN protocol, and all other protocols, they working through PCI-Express. But also there are few vendors who process cameras which directly stream into PCI-Express. I need to mention that usually such cameras, they are super expensive, but they give like one of the maximum available speeds, and usually it's like one of the best quality. Next one, GigE. It's a protocol over a regular network cable, which is using UDP with some optimizations over it. This protocol is pretty good for cameras, but it's just LAN variant. CoaXPress, it's high-speed data transfer standard, developed for computer vision and other application. It's based on serial communication protocol, and basically it's like the same CSI usually. But the main like idea about this connectivity, it's like coaxial cables which can give you pretty long distance. And there are a lot of fixed like cameras for this protocol and like board connectors which can serve it. But as I mentioned, it's like physical part of different existing protocols. GMSL, it's the different option which can be used to wrap like CSI protocol on the hardware level, but it's like the other option. The same, it's about FPD-Link. Among them, I need to mention like HDMI. It can be used to transfer video. In some cases, for example, if you catch image from your monitor, it's like HDMI, it's one of the protocol which can be used to receive it. And of course, I didn't mention a lot of different protocols, which is like less than 1% of protocols, but among them I need to mention that, for example, there are some wireless protocols where like some wireless connectivity like Bluetooth or Wi-Fi, it's integrated directly in the camera. Of course, there are some protocols on super low level where it's like your matrix can be directly connected to your chip, and of course it's like but all of them, it's not like mass protocol on the market, but main one was here, I assume. Next one, it's like interface speed. Interface speed and the signal delay, these are two most important and crucial characteristics when you need some real-time recognition and when you need like some reaction of what is happening. Of course, like the fastest one, it's like PCIe and probably CSI connectors, but in general, you need, when you're thinking about this, you need to think also about like, will the camera use some compression or like stream directly in your memory? Which compression it will be, how you will decode your compression, and so on. And of course, but usually today, most of protocols, they are just limited by PCIe capabilities, and even like for modern USB 3 point something and CSI protocols, these speeds, they are near the same. But for example, like for CSI protocols, you can scale amount of lines. For USB, like it's a little bit faster than regular CSI cameras. But in general, if you need like to have more than 500 frames per second, you need to go deeper and optimize. If you need less, usually there are some available cameras on the market which can easily give you such speeds. Of course, when we're speaking about like high speed, like 500 frames per second or 1000 frames per second, usually it's not about the full resolution and it's about some decreased resolution. So, also the latency, it's like the function of all this. Speaking about optical scheme, like it's a topic that can like be discussed endlessly. There are a lot of articles and of course like books about each part of this topic. Like for example, all characteristics about like focal length, aperture size, like and all other optical parameters. It's like there is a general physics, of course, behind them, but there is a lot of optimization about how good lens, what it's doing like with some anomalies or on the border of your image, how they look like, how you can calibrate different lenses where this calibration work better, and so on. I don't want to go deeper, I just want like to mention high level what you need to choose. And of course, like you need to choose like focal length, you need to choose aperture size, you need to choose like probably some lens mechanization, like do you need some zoom, do you need some autofocus, maybe if you need some additional characteristics to automatically choose like aperture size. When we are speaking about lenses, it's also important like to speak about like coating of all these lenses and of course about filters. For some application, like you need to have like infrared filter. Also, all these filters, they can be installed like on the lens, or sometimes directly they can be installed on the matrix. And you need to choose all this if you need like to work in special spectrum. You need to choose which part that there is no additional filters, because for example for matrix it's pretty often when companies install this IR cutting filter directly on the matrix. So And we already start speaking about metrics. And speaking about the metrics, you need to choose a few high-level characteristics like metric size, and it's two questions. One of them it's like amount of pixels, and the second is the physical size of each one of the pixels. Because like the number of the pixels, it's your resolution, and the physical size, it's your photosensitivity and amount of noise in each pixel. And it's super important when you work in, for example, in some low light condition, you need to have a big pixel size to have a lot of lights. Also, when you're working with super small matrix with super high amount of pixels, usually it's become critical like for your optics quality, because can your lens like have enough resolution to cover all this matrix. And also you need to think about like, are you close to physical limits? Because sometimes when you see this, like, I don't know, 100 megapixel matrix with size less than my fingertip, then probably it will not have good resolution even with like the best lenses on the market, because it's just will be near the physical limitation. So when you thinking about matrix size, just think about not only about pixels, but also about physical size. The bigger physical size, the better will be quality of the image, but the more money you will spend on your lens system. Speaking about metrics, we also need to think about like sensor type, and sometimes it's pretty hard to understand which sensor, like which matrix are using. It's not like the characteristics that 100% of people need to know. But for example, if you work in some special condition, for example, you need super high frame rate for like, I don't know, eye tracking, or for example for some stars recognition, you need to think a little bit about like the metrics and how it was produced, because like of course everyone know about like CCD and CMOS matrix. However, it's like today it's a little bit deeper, because like CCD, it's pretty old and mostly used in some specific applications. I like worked only with astronomical cameras, like with SSD, but there are also some more specific like production application where they still are working. And CMOS is the main format right now. However, it has a lot of technologies around it, for example, like front light illumination and back light illumination, and it's like crucial on like amount of light that each pixel receives. Like it can be like twice determined, because like of these characteristics. Also today, like it's pretty popular to have stacked matrix, and with stacked matrix, it's like theoretically like the maximum amount of light for each pixels, because like each pixel has like consume only light waves of ink lengths, but of course it's not like, in reality it's not so excellent, and it's a little bit more complex function. So if you need like specifically work on some like light frequencies, or when you need like to maximize your sensitivity, you need to think a little bit about your metrics. Also, sometimes there are some special characteristics of some matrix. For example, some matrix has internal HDR technology, where they can like switch from different times, like exposure times, and like have additional information about like overlight. And like metrics today, they like a little bit smart processors which can like process the images and take the image according to environmental condition. But it's like it's a big question: do you need to use this every time or only in some specific cases? And of course, there are like a lot of characteristics that you can meet in some special hardware. For example, like sometimes you can find like matrix mechanization, especially in some consumer optics, for example, like in photo cameras. For example, like in this one camera, matrix, it can be like shaked a little bit, and it can compensate some movement of the camera. Also, it's important, for example, when you work with astronomy, to have like active cooling on your matrix, but it's more like 99.9% that you will not have this when you just choose your matrix and camera for your AI project. But sometimes it's a possibility, so I just mentioned this. Of course, there are a lot of other ingredients I didn't mention, and the first of all, of course, I like mentioned this a little bit, but it's like your light system. Sometimes you need to choose like how to build this from the scratch, or some cameras, they already have this light system. For example, like surveillance cameras, they often have like internal lighting. Also, some special cameras like that built for robots, or for example for 3D, they often have this infrared illumination. When you're thinking about this illumination, you need also to think about like spectrum of it, like the point of installation and so on, because like when you're looking directly from your cameras, you will have a lot of glares, and you need to think about how you will fight them. So this light system, it's a pretty complex question. Also, it's important to think about like shutter type, because of course there is global shutter or rolling shutters. Global shutters allow you to exposure like exactly the same time interval for each one of pixel, and rolling shutter will give you like there are a lot of techniques for rolling shutters, but usually it's like each line will have its own time of exposure. And you need, if you're doing something with high speed, you need to think about this a little bit. Of course, it's important to understand, do you need like camera with some CPU, NPU, GPU image capabilities? Because if you need camera like where you already have all your processing power, it's not a lot of such cameras on the market, and a lot of companies, they prototype them themselves. So this was like the first general part when we discussed all these general possibilities about cameras. But let's go a little bit deeper, and let's discuss like about USB, about CSI, and about line cameras. Here we will like go a little bit deeper in each one of this protocol and discuss a little bit more about like pros and cons of each one of them, and also I will show you a few examples of, in my opinion, pretty appropriate cameras for each one of them. Okay, let's start from USB, like the most common one, in my opinion. No, I don't have any USB cameras around me, but anyway. And of course, when we are speaking about USB, the first advantage, it's like all the processing, usually it's working on your USB camera. And because of this, you optimize your channel pretty efficiently. You just stream compressed video, and it's pretty nice. You don't need to think about this. And with USB, it's just plug and play. It's like the easiest format among all these cameras. It's working like with Windows. Most USB cameras work with with Windows, with Linux, with MacOS, even like you can connect your camera to Android, and usually it's working. So it's pretty nice, and it's nice to have something plug and play. And the third advantage is availability. USB camera will be sold in any nearby store near you. Of course, not every USB camera is so easy to buy. When we're speaking like that, it's available. Usually it's for most simplest camera, of course, and like the most consumers camera. When we're speaking about some specific camera with specific protocols, blah, 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 in this case, we need like to think, of course, it's like the same as any other camera. And the fourth advantage is that USB has very fast protocol. Let's speak about cons of USB. And the first disadvantage, it's limited cable length. Of course, it's not like the critical, but it's the point where you need to think a little bit in advance. In general, like if you buy the general USB camera, the length of your cable will be like 1 meter, probably 2 meters for good cameras. But it's pretty often not enough. If you will buy like cable with active amplification, it can give you like 5, maybe 10 meters. If you're thinking about like optical cable, it can be much longer, but it can cost like comparable with a good USB camera. For example, like this cable with lengths of 100 meters can cost up to $350. And of course, it's not a limit. And also when you have a long cable, you can have a lot of problems with this cable. So in general, it's not recommended to use like USB for long distances. In many cases, for example, if you are building camera and wants metrics with USB interface, your USB length will be like a few centimeters. But in general, with USB, you need to think about this if you want like to use it for some surveillance or for some, like, I don't know, camera cases when your USB installs in camera. The second important minus, it's like simple cameras can have a large delay, and also this delay can be unstable. Because you don't have full control over this protocols inside camera, over like this compression, you don't know when you will receive the answer, like the image from your camera. It can be like 100 milliseconds after it was shot, maybe even longer, but maybe your latency will drop. So it will be pretty hard for you to investigate here and to have some reliable result. But of course, if you will buy like expensive camera, probably they are a little bit more stable in this direction, but you need to test all of this, because pretty often like vendors, they don't write anything in case if they have bad cameras, and only on like some top USB cameras they are writing like we are pretty stable. So, and usually it's just not enough information about each one of the camera, will it work or not. The third minus, sometimes finding a USB camera with exactly characteristics that you need isn't easy. Like there are some cameras on the market, some of them more expensive, some of them are less expensive, but if you need something specifically for your case, and it may be that it will be only super expensive cameras, and maybe you will not find, and you need like to communicate directly with vendors to produce such cameras. So amount of some rare cameras are limited. And the final cons point, it's like some drivers can be unstable. Recently, maybe last 5 years, I don't have such troubles a lot, but like 6 or 7 years ago, a driver, even for Basler camera, which one of the best in my opinion, could freeze on Jetson, require system reboot, and it was a lot of issues with USB drivers, with different boards. And I'm almost sure that today you also can have such problems if you work in like not with main vendors, but for example, if you take in some unnamed like Chinese board and unnamed camera, it may have some problems with like stability from the driver side. Okay, let's speak a little bit about when to use USB cameras. And in my opinion, like they are super good for prototyping. They allow you to quickly connect and minimize problems cased by drivers and codecs. Very often, like I saw small scale indoor solutions that was built exactly like only on USB. And but usually it's like in case like if you can spend a few $100s on your camera and it's some like constant environment, it's super easy. Like for example, I mentioned like Basler cameras, they can cost like few $100s, and your like processing unit can cost like $1,000, and your lens can cost like few $100s. And if in some cases when like it's just some custom production and it's not a big problem, then it's okay to use like expensive USB cameras. Also, USB cameras are good for providing high frames per second rate, and I saw a few solutions where they were used just because of this. Let's go through a few examples of USB cameras. Of course, I already mentioned like Basler camera. Also the good ideas from one of the guys who helped me with these articles. It's like Logitech C270 cameras, and actually I saw them in a lot of projects because they like pretty stable. It's like old Nokia phone. They like working almost every time. They lightweight, you can buy them in every store and so on, but of course it's like not great resolution today. It's like pretty old camera. It's not like excellent characteristics, but if you need something to test quickly, they are okay in my opinion. Like not the worst lens, working everywhere and so on. Next one, when I mentioned like about Basler, of course it's not the only vendor, and of course there are like a lot of Chinese competitor, and in my opinion like this Vision Datum, it's one of the nice one. It's like significantly cheaper than Basler. They have a lot of cameras. I saw them in a few projects and usually they work pretty nice. But of course, like there are 1,000 cameras like this. You just can Google this, for example, on AliExpress, and you can find a lot of them. All of these cameras, it's like pretty professional cameras for USB, where like everything inside the box. Fourth option, of course, you can buy some USB chip with like some camera chip with USB connectors. And in my opinion, like these few small USB boards, they are super nice. They almost the same size as your Matrix. They can provide good USB connectivity, and they were recommended to me by Yuri and as far as I understand it, he used them in his projects, so they are also pretty nice and reliable. Okay, let's switch to CSI cameras. And the most configurable protocol, in my way, is CSI, of course. You can use different number of PCIe lines or different approach to transferring your data, like with compressions, without compression, like you can. There are some options. Usually you need to decode your CSI with some additional chip, but of course it's some questions about how you can transmit this. Camera can transmit raw information, and you can go deeper in all these protocol questions, and with CSI protocol you can optimize camera specifically for your case. There are a lot of camera vendors. You can choose a camera that suits your special task. And since it's pretty low-level protocol, there will be a lot of ways to choose, a lot of ways to optimize it specifically for your task. And of course, even on this CSI, you can use a lot of different connectors that I mentioned previously and transfer through them. Speaking of cons, it's with great flexibility came a great amount of time that you need to spend to optimize everything. Of course, there are some CSI cameras that work out of the box, for example, Jetson cameras or so on. We will talk about them a little bit later. But it's one of the main in question. Speaking of different cons, limited line lengths. By the default, it's usually 30 centimeters maximum distance. Of course, if you will use some special connectors and protocols, it can be 10 meters. But the longer it will be, the more money you will spend on all these peripherals, connectors, and so on. If your board doesn't have a separate chip for image encoding, you should do this on processor, and usually it's a case for some small boards like ESP32, and of course it's additional time for your main CPU in this case. And you need also to understand that with CSI, sometimes you need to spend a lot of time on this low-level work. For example, some cameras require mutual calibration of the camera and the board, on this data transferring. And actually, I saw a few projects where all this technical questions about CSI cameras, people spent a few months on all this question to choose optimal camera, to set up all protocols and calibrate them. So you need to invest a lot of time in if you want to use them, especially in case if you creating your own board. So when to use? When you need maximum control over your system, when you need to achieve the minimum production cost, when you need to have maximum speed, and of course minimal latency. And usually if you're developing your own board, using CSI is pretty logical solution. Of course, you can use USB and some USB boards, but CSI, in case if you're developing everything from scratch, seems pretty natural. So a few examples, and of course I will start from Raspberry Pi cameras, and they actually working on a lot of boards, and it's pretty nice. There are a lot of cameras for Jetson. You can find them on NVIDIA website. Of course, I used some Yacon Systems cameras. They were okay, but I saw a lot of comments that they are too expensive for their capabilities. Here it's like another list of different low-level cameras and like low-level chips. So if you creating your own camera, probably you need like to Google a little bit deeper in all like vendors, what you can order, all characteristics and so on. So our final part will be about LAN cameras, and it's pretty nice protocol because everyone have it in home. If you're watching this video, probably it was delivered to you through your networking, and it's almost the same. And usually all the cameras, like, it's just out-of-the-box solution, which working even more stable than USB, because if the camera streams, then you can catch the stream. And it's pretty nice because out of the box, it's pretty often that there is a lot of solution with your light system. It's pretty often when like lightning already integrated in such camera. Such cameras has multicast, so you can connect to such camera from a few users. And of course, there are many cameras on the market. You can find the only like the good camera with your lens, with your like specific case that you want to use, and so on and so on. Dust, moisture protection, with some heating, with some anti-fogging, anything. Rotation, zoom, pointing, some like autofocus control, everything. But of course, like the main cons, it's like high latency, especially when you compare it like with USB SSI. You buying something like you buying a box, it's pretty hard to configure anything. Of course, there are cameras with better configuration where you can have access to like low-level work of this camera, but usually it's like pretty high level. And of course, if you buy like camera with already in case with lights, it's like pretty useless to install additional light system on such camera. So when to use, when the main idea, when latency is not important to you, when you like processing center is far away from your camera, when you need to have a few processing centers for the same cameras. And a few examples. With LAN cameras, I prefer to look at this like there are a few tiers of vendors, and for each tier you have different stability and different quality of the box. And of course, on the highest tier, probably like Axis and Moxa, it's two like most popular companies. They producing like super nice camera, but they will be super expensive. In the middle class, it's like HikVision and Dahua. They are pretty nice. I use them in a lot of projects, and a lot of my friends use them in a lot of projects. And in my opinion, like HikVision, one of most oftenly used camera. Of course, when you're choosing camera, you need to choose camera with characteristics, especially for your case. Speaking of the cheap cameras, you can go to AliExpress and just put like LAN camera. But remember that each one of them it's lottery. Even if you brought some camera like a few years ago, today same brand camera may have completely different chip, completely different protocols and so on. So usually it's worth to, if you need like if you are good enough with such types of cameras, you need just at the beginning to buy a few of them and test them. So we, in some project like 4 years ago, we did this. It worked pretty nice, but it's like each time when you choose a camera, you need to go through this again because all the market situation can be completely different. So, small summary. There is no straightforward solution for this question. Even top companies experimented a lot. It's a common procedure when you like buying a lot of cameras. If you already have a product, you buy different cameras with similar capabilities that you're already using and comparing them with your current ones. So the best approach if you're choosing a camera from scratch, it's just schedule some additional amount of time to research this question. The main loop here, it's like start from table of physical and legal requirements. For example, sometimes you need to use specifically like LAN protocol from a legal point of view, or some others or some specific cameras that's certified for your environments. Based on this, you need to choose like optical scheme, like light, power supply, like the second type of physical characteristics, but which you can like manipulate a little bit. Based on this, you choosing like connectivity and protocols. Like you can switch some protocols from one to other. So basically on this level, you just trying to minimize amount of cameras that like in your field of view, or in special case, if you don't have some specific cameras with physical characteristics that you need, you looking on different protocols which can be used switch to your protocol. And if there are still fewer possible cameras, probably it's easier to buy all of them and test them, or just to choose like the simplest solution. For example, if you have as a final idea like USB and CSI camera, probably it's better to take USB camera because there will be less work with USB cameras. And of course, while you're waiting the camera of your dream, maybe it's just easier to take a simple USB or LAN camera in your local store and use this while like your final camera will be not delivered. So thank you for watching. I hope it was helpful. Bye.